In this research paper titled, Low-Resource Neural Machine Translation Using Recurrent Neural Networks and Transfer Learning, a case study on English-to-Igbo, the authors, Okeme Anthony Eckel and Biswarup Das, explore ways to improve machine translation for languages that don't have a lot of available data. They focus specifically on translating from English to Igbo, which is a low-resource African language spoken by over 40 million people in Nigeria and other parts of West Africa. Igbo is an example of many languages around the world that are underrepresented in AI technologies, making this work important for bridging that gap. The paper begins by discussing the broader challenges in machine translation, a key part of natural language processing. Machine translation involves automatically converting text from one language to another while preserving the original meaning. Over the years, researchers have used various approaches. Early methods included rule-based machine translation, where systems followed predefined linguistic rules. Then came statistical machine translation, which relied on analyzing large corpora of text to find patterns. More recently, hybrid methods combined these ideas. But the real breakthrough has been neural machine translation, or NMT, which uses deep neural networks to handle translations more effectively. NMT typically employs an encoder-decoder architecture. The encoder takes the input sentence, processes it, and converts it into a numerical representation. The decoder then uses that representation to generate the output in the target language. This setup, especially when enhanced with attention mechanisms, allows the model to focus on relevant parts of the input sentence during translation, leading to more accurate and fluent results. The authors note that NMT models learn faster and produce better translations than older methods, thanks to their ability to capture complex patterns in language. In this study, the researchers zero in on recurrent neural network-based models, particularly those using long short-term memory, or LSTM, and gated recurrent units, or GRU. These are types of RNNs designed to handle sequences of data, like sentences, by remembering information over time. This is crucial for languages because words in a sentence depend on context from previous words. To boost performance, they incorporate attention mechanisms, which help the model weigh the importance of different parts of the input when generating each word and the output. The dataset they used is a key part of their work. It's a carefully curated collection of texts from various sources, including Bible corpora, local news articles, Wikipedia entries, and data from Common Crawl. All of this was verified by native Igbo language experts to ensure accuracy and quality. This step is especially important for low-resource languages, where clean and reliable data is hard to come by. The researchers trained their models on this dataset and compared their performance to existing benchmarks for English-to-Igbo translation. Their RNN-based system, using LSTM and GRU with attention, achieved results that were competitive, meaning it matched or came close to the best available systems at the time. To take things further, they applied transfer learning. This technique involves taking a pre-trained model that's already good at a related task and fine-tuning it for the specific job at hand. In this case, they used MarianNMT, which is a popular framework for neural machine translation, integrated within the SimpleTransformers library. By doing this, they were able to leverage knowledge from models trained on larger, more resourced languages and adapt it to English-to-Igbo. The results were promising. With transfer learning, their model saw a significant improvement, gaining about 4.83 points on the BLUE score, a standard metric for evaluating translation quality. This brought the estimated translation accuracy up to around 70%. BLUE measures how closely the machine-generated translation matches human translations, so this gain highlights how effective combining RNNs with transfer learning can be for low-resource scenarios. The paper also mentions using the teacher forcing algorithm during training. This is a technique where the decoder gets the correct previous words as input, which helps the model learn more efficiently and produce better outputs over time. In terms of contributions, this study presents what the authors claim is the first high-performing translation system for the English-to-Igbo pair. It incorporates advanced features like attention mechanisms and global attention, which allow for more precise handling of long-range dependencies in sentences. Global attention, in particular, lets the model consider the entire input sequence when deciding on each output word. Overall, the findings underscore the challenges and opportunities in translating low-resource languages. By combining RNN architectures with transfer learning, the researchers demonstrate how to overcome data limitations and achieve meaningful improvements. This approach could be applied to other underrepresented languages, helping to make AI more inclusive and accessible worldwide. The authors provide context on their affiliations. Okeme Anthony Eckel is at Tennessee Technological University, and Biswarup Das was at the Moscow Institute of Physics and Technology during the research. They emphasize that both contributed equally, and the work was conducted while Das was at MIPT. In the computing methodologies section, the paper classifies this under machine translation in natural language processing, with key phrases including neural machine translation, low-resource languages, RNN, LSTM, and transfer learning. The archive reference is 2504.17252v1 from April 24, 2025. Indicating this is a preprint shared for community feedback. This research not only advances the field for Igbo but also serves as a case study for similar efforts in other low-resource languages, potentially influencing future developments in global NLP applications.